Stanford University.
Welcome to Stanford CS 193P, Developing Applications for iOS, winter of 2017. This is lecture number 7, and today we're going to talk a little bit more about Swift. And once we do that, we can introduce some technology that we need to do more sophisticated UI kit objects like UIScrollView is going to be our first example of that today. So we'll have a demo at the end where we show you how to use UIScrollView. First thing I want to talk about in Swift is error handling. So far, we have not called any methods that can generate an error, or what we call throwing an error. And we can always tell these methods, though, really clearly in any API, because when they're declared, they'll have the word throws after it. And throws means that somewhere in the processing of this method, it's possible, but not guaranteed, that it will throw an error. Okay? So when it throws that error at us, we have to catch the error. And the way we catch it is, well, first of all, every time we call a method that can throw an error, we have to use the word try. Okay? So we have to try that method because it might fail. So that's why we use the word try. But if we want to catch the error that comes back, we actually have to do that little try inside what's called a do construct. So we have to say do, open curly brace, and then some code that has some tries in it, and then close curly brace, catch. Then let error is going to allow us to grab the thrown error into a variable, in this case called error. We could say let any variable name we want. That's going to be the variable that has the error in it. And then in that curly brace, we handle the error. And then after we've handled it, our code continues. Okay? So we caught the error, we deal with it, we keep going. If we want to, and if our function throws, we could rethrow the error by using the keyword throw there in our second little curly brace space. Now this error that gets thrown to you, it does have to be of a certain type. The type is called error. It's a protocol, which I'm going to talk about later in this lecture, but it's a pretty simple little type. And in UIKit, when UIKit methods throw an error, they throw an error of this type NS error. So you can go take a look in the documentation for NS error and see what an NS error is. It has an error code. It has an error domain, like where the error occurred. And it even has some things like a description of what happened, why it failed, things like that. Now, sometimes we call a function that throws and we know for sure it's not going to fail. This is rare that we know this, but if we're certain about it, we can use another version of try, which is try exclamation point. And just like exclamation point means to force it in an optional, exclamation point here means to force it essentially. And if we call context save right here, whatever that function is, if we call it and it throws, our app will crash. Okay, that's what the try exclamation point means. It means try, I know this is not going to throw. If it does, crash my app. There's yet another try though, which is try question mark. Try question mark means try to call this method that throws, and if it does throw, just give me back nil. Well, for that to work, of course, the variable that we're assigning the result of this method, I called this one error-prone function that returns an int, whatever that returns is now going to return an optional version of that. So error-prone function that returns an int obviously, but x, this let x equal, that x is going to be an optional int for obvious reasons, because if error-prone function that returns an int throws, it has to throw nil back at us. Okay? So that's what try question mark is. Try question mark is give it a try. If it fails, just give me back nil. If I do this try, I don't get to look at the error. I don't know what it is. I'm ignoring the error here. Okay? I know there was an error, but that's all I know in the try question mark case. So it's a very simple error mechanism, works quite well in Swift. They really learned the lessons of some other languages that have more overwrought, overcomplicated throwing of errors that are throwing up call stacks and all these things. Swift is very straightforward. This is the entirety of the error processing. All right, Now they're a completely different topic, extensions. So an extension allows you to add a method, or a var even, to another class or struct or enum that you may not even have the code to. Okay? It's called extension because it extends that class. So here's a concrete example to help you understand why we might use an extension. Remember when we did our app last time and we went to our storyboard and we wrapped the detail of the split view in a navigation controller and it broke our code, right? It broke our code in Prepare for Segway because that code was looking for a face view controller and it found a navigation controller instead. And the way we fixed that is we just looked to see if it was navigation controller first, and if it was, we looked at the visible view controller of the navigation controller. Now we had our face view controller back again. Now we could put that code into an extension of UI view controller by creating a new var. You can see it right here, called content view controller. We can call it a new var anything we want. I like content view controller because if it's a navigation controller, it's the content. If it's not a navigation controller, it's just self. It's the view controller itself, it's its own content. And so I can add this. So I'm adding this var actually to UI view controller. So now UI view controller understands this var. It has this new var. Now I didn't subclass UI view controller to do it. I just extended UI view controller. So UI view controller and all subclasses of UI view controller will now have this var. And it makes that code that we had in Prepare, which looks something like this. The green part is the same in both places. It changes that code with all that to just this simple line of code. The Segway's destination, content view controller as my MVC. Okay? I think that slide says destination view controller, but really that should be segway.destination.content view controller there. Okay? So it just cleans up our code in Prepare for Segway. But the extension that we add to UI view controller is purely a UI view controller thing. It had nothing to do with our emotions view controller or anything like that. We purely extended UI view controller to have new functionality. Okay? Now, extensions inside their code, they can refer to self, and when they refer to self, they mean the class they're in. So in this case, this self means the UI view controller that is executing this var, which makes sense, right? There's some restrictions, though, with these extensions. Okay? So extensions are not a substitute for everything object-oriented, like subclassing and things like that. One thing is that you can't re-implement something that already is in there. So you can't override or subclass with extensions. Okay? You can only add new things that aren't there. And in fact, if UI view controller were to have implemented this var, content view controller, its version would win. The extension would not win. Okay? In fact, might even get an error when you try to add an extension to something that's already there. So it's not for replacing or overriding or anything like that. It's for adding new things. And a huge restriction to extensions is they cannot have any storage. An extension cannot have, the only vars an extension can have to be computed vars. They can't have any stored vars, okay? Extensions have no storage. They're purely for adding code. All right? Now, this feature of extensions is easily abused, especially by beginners to Swift. They start saying, oh, cool, I'll just add this code in an extension here, and I'll add in a code in an extension there, and I'll add it over there. And you start getting this kind of messy situation where the extensions don't really make sense for the class you added them to. So I'm going to suggest that you be kind of go slow and steady with extensions. Don't use them too much. Now, having said that, extensions can be super powerful for architecting your code well. Okay, and especially when I start talking about protocols, they can be a fundamental aspect of building like a functional programming approach to building your app. But I don't have time to teach all that to you, so you're only going to know enough about extensions to get yourself in a little bit of trouble. So be careful with extensions, okay? Use them lightly. But in the future, when you start becoming a serious iOS developer, someday you're going to want to learn how you can use extensions to your advantage without abusing them. All right? Next topic, protocols. Super duper important topic here. How many people have encountered protocols in other languages? Nobody, see. That surprised, well, one or two people. So it surprises me a little bit, but protocols, while very simple, are also incredibly powerful. So a protocol is a way to declare a type that really just means these methods and vars with no implementation, generally. Okay? That's what a protocol is. A protocol, as you'll see, is a type, but you're essentially just defining a few methods or even some vars that are part of this protocol. And then we're going to use the protocol, as you'll see, to define our APIs better. It allows you to create an API that lets the callers pass anything they want, any class or struct or enum even they want to this API that you create, but it allows you, who's receiving it, to ensure that that class or enum or struct implements certain methods or vars that you need. Okay? So that's what this is all about. It's about API design. We want to build API so we can express in our API exactly what we want and no more. Okay, just the methods and vars we need to do whatever this function's going to do or whatever, and not extra stuff. So a protocol is just a collection of method and property declarations. That's what a protocol is. But a protocol is a type. It's a full-fledged type. It serves any place you can use a type, like a float, you can use a type that's a protocol. Okay? Protocols are first-class types, absolutely first-class types. The implementation of the methods and vars in a protocol, since a protocol is just the declaration of them, where does the implementation happen? Well, mostly it happens in classes and structs and enum that claim to implement that protocol or conform to that protocol, we say. Okay? So if I'm a struct and I want to say, yes, I want to conform to protocol X, then I have to implement all the methods and vars that are in protocol X, right? Because protocol X is just a declaration of them, it's not an implementation. Now, you can also do implementation of a protocol in an extension, but I'm going to put that on the shelf for a second and talk about that in a few more slides. Okay? But primarily, a protocol's implementation happens in conforming or implementing classes, structs, and enums. Now, the three parts to a protocol. One is the declaration of the protocol. That's really simple. It looks just like declaring a class or a struct or an enum, but there's no implementation. Okay? The second part is the class or struct or enum that claims to conform to that protocol, that claims that it implements that protocol. And then, of course, there's the actual code that class, struct, or enum that claims to implement the protocol actually does implement the protocol. So that's it. Those are the three parts of using a protocol, both the declaration and then the implementation. Now, I'm going to talk about a feature with protocols called optional methods. This is not optional like the optional type. This is a different optional. It means that the methods in the protocol are optional. You don't have to implement them, and you can still say that you implement this protocol. Now, this is an Objective-C thing. This is not really a Swift thing. In Swift, when you have a protocol and it has a bunch of methods in it, if you're a struct or a class and you want to say you implement that protocol, you have to implement all of them. All right? In Objective-C, though, that's not true. In Objective-C, some of the methods might be optional, in which case you can claim to implement the protocol and not implement those. So if we have a protocol that has these optional things in it, it has to be marked OBJC. So you put this little @ OBJC before the word protocol, and that says this is an Objective-C protocol. And then inside the declaration, you can put the word optional in front of any funcs or var that you want to make optional. Okay? So this is going to be used for something called delegation, which I'm going to talk about in a few slides, which is an Objective-C thing that is brought forward because it's in UIKit so extensively. It's brought forward into Swift using this @ OBJC protocol. Okay? But back to protocols in general. So let's take a look at what a protocol looks like to declare. So here's the declaration of a protocol called some protocol. And you can see it looks just like declaring a class, a struct, or an enum, right? You got the keyword, which is protocol instead of class, struct, or enum, and then you got the name. Now, after that, though, there's a colon and other protocols. These protocols are called inherited protocols. Some protocol inherits these two protocols. And what it means is that anyone who wants to say, yeah, I implement some protocol, they have to implement those too. Okay, they have to implement all three of these protocols, some protocol and its two inherited protocols. So protocols essentially have multiple inheritance. How many people know what multiple inheritance is in object-oriented? Only a few of you. So multiple inheritance just means like you could have 2 superclasses or 3 superclasses. Some languages support that. Swift does not, but Swift does support multiple protocols that you can inherit from. Okay? Now, the protocol inside, you can have properties and you can have funcs. And if you have a var, a property, you have to say whether it's a get and set property or whether it's just get only. And you do that with the curly brace get set or curly brace get. So you have to put that curly brace something in there that says whether you're going to be a get set var or whether you're just a get only var. Any function that the protocol expects would mutate the thing implementing it, like a struct or implementing it, you have to mark it mutating. Now, if a class were to implement this protocol, it wouldn't matter, because classes don't have to mark themselves mutating. And in fact, it's even possible to say, I want this protocol only to be implemented by classes. And you do that with putting the word class right after the colon. See the yellow class right there? Some protocol colon class. That means this some protocol can only be implemented by reference types. And in that case, you don't have to put any mutatings in there. But if you're going to allow your protocol to be implemented by an enum, or especially by a struct, obviously, you're going to have to put mutating in there. You can also specify in your protocol initializers. You're basically saying anyone who wants to implement this some protocol has to be able to be initialized with these arguments. All right? If you do that, by the way, and you're a class, okay, then you have to mark the initializer required. I'll show you that in a second. All right, so how does a class or a struct or an enum say, yes, I implement some protocol? It does it this way. A class, right after its superclass, just puts a comma and the protocols it implements. And it can implement any number of protocols there. So this class, called SomeClass, has a superclass. It's called superclass of SomeClass. And it also implements two protocols, some protocol and another protocol. Now, inside of some class's implementation, it must implement all the methods and vars in those two protocols, unless it's an Objective-C protocol and they're marked optional. Okay, the methods in there are marked optional. That's the only exception to that. All right, structs or enums, exactly the same. It's just they have no superclass. So here's an enum saying that it implements those two protocols. Okay, and here is a struct saying that it implements those two protocols. Now, you can have any number of protocols implemented, and as I said, the inits have to be required. The reason that these inits have to be marked required here is that what if a subclass is SomeClass right there, and it does all the initialization game such that this is no longer a good initializer, because maybe this was a required initializer and you didn't override it, so now you have your own new designated initializer, et cetera. Well, that would be bad, because that would mean the subclass of SomeClass would no longer conform to that protocol. And that is not allowed. If a class conforms to a protocol, like some protocol, all of its subclasses have to continue to do that. And they'll inherit that from their superclass, except for inits are the one thing that can be uninherited by the rules of inits. Okay? One thing that's very interesting is that you are allowed to add protocol conformance to a struct, a class, or an enum using an extension. Okay? As long as you can do it without any storage, you can do it in an extension. You just say extension, something, where something is the class, struct, or enum, colon, some protocol. And that's saying I'm creating an extension to that class, struct, or enum that implements this protocol. And then inside that extension, you have to implement all the methods of the protocol. Okay, understand what I'm saying there? Okay. Let's talk about protocols being types. What do I mean when I say a protocol is a type? So I got an example here. I've got a protocol called movable, and it just has one function in it, a mutating function called move2point. Now I have two data structures here. One is a class called car, and it's movable. Okay, the car is movable, but the car has other methods like change oil. You can change the oil of the car. And similarly, I have this struct called shape. It also implements movable. Look, see, mutating func move2point. It actually implements that. But it also has a function called draw, because it's a shape and it can be drawn on screen. All right? So all three of these implement this, all two of these classes implement this protocol move2. Do you see that? So do you see that they're all movable? Okay, a car is movable, a shape is movable. That's how we would describe those. So I created two little vars down here, a Prius, which is a car, of course, equals a new car, and then I created a square, which is a shape, of course. So I've got a Prius and a square here, and let's see what we can do with the Prius and the square. First, I can create a var whose type is movable, called things to move, and I can assign it to Prius, because a Prius is movable. So if I have a var that is of type movable, of course a Prius can be put in there. Everyone understand that? And I can even say thing to move, move to this point, because thing to move is a movable. So if it's a movable, it has to implement move to point. So I can say that. However, I cannot say thing to move, change oil. This is the critical thing to understand. Okay? Even though I put a Prius in thing to move, that var is not a car, it's a movable. And movables don't know how to change the oil. Cars do, but movables don't. So what matters is the type when it comes to sending the messages, not what's actually in there. Everyone understand that? Now, of course, I could also say thing to move equals square. That's perfectly legal as well. Okay, square is not even a class, it's a struct. Okay, it's not a car, it's a shape. But they're both movable, so that var, thing to move, which is of type movable, can hold either of those things. In fact, I could even create an array, things to move, which is an array of movable, and then I could put a Prius and a square both in there. Even though they're completely different classes, types of things, okay? They can both go in there because they're both movables. So the type of thing in that array is movable. What it actually is doesn't matter. Okay, are we cool with that? All right, I could also have a function that takes a movable as an argument, like slide, that takes a slider, which is a movable, and I can say slider, move to that position, because the argument slider is a movable, so we can send move to. And I could say slide a Prius, slide a square. Works perfectly fine. By the way, you can have arguments to functions that require multiple protocols. For example, I could have a function slip and slide, which has a parameter x, which is both movable, and another protocol, which I haven't shown here, called slippery. And that's what the ampersand means. It means both of these protocols. So that inside slip and slide, I could send x movable things like move to, and I could also send it slippery things, whatever those are. Note that I can't say slip and slide Prius, because Prius does not implement slippery. Okay, Prius does not conform to the slippery protocol, so cannot pass in there. Swift would not even let me call that. Okay, everyone understand what I mean now by a protocol as a type? It's just a type, and anything that conforms to that type can be stored in something or passed through in something of that type. Now, I'm going to take a couple slides here and talk about the advanced use of protocols. I'm not going to ask you to do that in the 9 or 10 weeks we have here, because it is kind of advanced use, but I think it's important that you understand that this exists, because all of Swift's standard library, arrays and dictionaries, all that stuff, is all implemented using protocols. Okay? So one thing that a protocol can do, that I'm not going to ask you to do, is that it can restrict the type of a generic. Everyone knows what a generic is, right? An array of angle bracket T means that the array can hold any type in there. But that array of T, could be restricted to things that implement a certain protocol. So here's an example, which is range. When I showed you range a few lectures ago, I said it was sort of range angle bracket T. Okay, the reason it was only sort of range angle bracket T is because actually range bound, or T, bound is just a variable name basically for that type, colon comparable. Okay, so a range can only be a range of things that implement the protocol comparable. Luckily, ints implement comparable, floats implement comparable, string characters and strings implement comparable, etc. So these things all implement comparable, so you can have a range of ints, a range of floats, whatever. Okay, now why does range want the thing in its range to be comparable? Well, it's because it wants to make sure that its lower bound is always less than its upper bound. I think on the other slide I said it was start index and end index, which is actually not range, the range struct, that's countable range, and those kind of things have that. You rarely use just a straight range. You're almost always using the countable range or closed countable range or one of those. But anyway, so that's why it wants the type that it can be generic for to be comparable. So being able to restrict these generic types by some protocol is really super powerful, okay? Because it allows you to build much more wide variety of generic data structures, because you can make it so that they have to implement certain things to work. All right. Now, also, you can use generics to declare protocols. So you can have protocols where the methods in vars might be a generic type. Okay? So now you can have these protocols, kind of meta, but you can kind of have these protocols that can be describing behavior that can work on generic types, or maybe work on generic types that implement certain protocols. Okay? Now, this is probably hard for you to imagine where this could go, but it really can go. Okay? So you're really opening up a lot of power here by adding generics and constraining these generics using protocols. Again, remember that you kind of get multiple inheritance with protocols, and I'm going to show you an example here with countable range. So countable range is the type of struct you get if you use 3 ... less than 5. Remember I showed you that? Like if you're doing a 4 in and you want to come 4 to 5 not inclusive, use 3 ... 5, you get this countable range. Well, let's think about what countable range is. Countable range is a struct that implements a ton of protocols. Okay, here's some of the interesting ones it implements. Indexable base, which gives it start index and end index, which I showed you on that slide kind of erroneously as range. It also implements this method index after, so a range can move forward because you can always find the next indexed. And it also does subscripting, so you can take a range and get subscript sub 3, and it will get you the fourth one in there. Right? So that's all that protocol is called indexable base. Then there's another protocol called indexable, which actually inherits from indexable base, which has index offset by. So now you can move through the range more than just to the next one. You can move farther ahead. There's also bidirectional indexable. Now you can go backwards, index before. Okay? So these things like start index, index after, index offset, index before, these are just methods in these protocols. Okay? It also implements this very important protocol called sequence. And the main method in sequence is make iterator, which gives back an object that can do the 4 in thing. So a range, that's why range works with 4 in, because it implements the sequence protocol. And it also implements the collection protocol. Collection is primarily just an indexable sequence, so it implements both those protocols. Things that are collections implement both those protocols. So why does Apple go to all the trouble to take something simple like a countable range and make it implement all these ridiculous protocols? Well, here's why. Because array also implements all those protocols. And so does dictionary and set and string.utf16view, the thing that lets you look at the Unicode characters in a string. All of these things do. So they're all sharing the same basic API description of their behavior, even though they're quite different. An array is quite different than a range. A set is different than an array, and certainly a character UTF-16 view is different than any of those things. A dictionary. So these are all different things, but they share the behavior of being indexable, being a sequence of things, being collections of things. They share all that behavior, and so that's described with these protocols. And wait, there's more, because of this thing I told you that extensions can be used to add code to a protocol. Okay? Now, there's a restriction there, of course, because both protocols and extensions can have no storage. So if you extend a protocol and give it some actual implementation by implementing some of the methods in the protocol, you can only use other methods in the protocol, or methods you inherit from other protocols, right? You can't use any storage. All you can do is call other methods and vars. But you'd be surprised how much you can do when you do that. And what that allows you to do, in this case, if you consider sequence, I told you that sequence mostly just makes you do that make iterator thing so that you can 4 in through the string characters or through the array or through the range or whatever. Well, if you just implement that one method, Apple has provided an extension to the sequence protocol that implements 24 other methods that are based on being able to iterate through, like contains. Is this thing contained in this sequence? Or joined by separator, which will take each thing in the sequence, turn it into a string, and join it by whatever separator you say, like a comma, and give you back a string. Okay? Or min and max, what's the minimum thing, or the maximum thing? Of course, in that case, the sequence would have to have what? Comparable items. Okay, because you have to be able to compare them if you're going to do min and max. Even those cool functions I told you, filter and map, remember those that took a closure and you were able to map an array from one thing to another? You can do the same thing with a range. And that code is not in array, it's in this extension of sequence. Okay? So now you're actually inheriting true implementation, true functionality. And you're multiply inheriting it. Okay? And you're doing it in a generic way, so the code works on arrays, string characters, etc., equally. Okay? So hopefully that's giving you some feel for like, whoa, what you could do if you had these protocols, if you designed your API using protocols, and then you could add code like this using extensions, you can hopefully see, and use generics especially, you can see how you could reuse a lot of code. Now, this approach, I actually mentioned it before, okay, this approach of focusing on the behavior of things rather than on the storage is leading to a methodology of programming called functional programming. Okay, and again, I can't teach you that, unfortunately, but I want you to know it exists, and maybe you can take a course here where you can learn about it. If you go out into the outside world, self-teach yourself if you have to. It's a very powerful mechanism for programming, and it's really, the protocols and generics play right into this because protocols and generics are all about the behavior of things, not about their storage. Okay? All right, that's all I can unfortunately have time to say about the functional programming and protocols. And now let's back way up off of advanced protocols and start talking about a couple of simple uses of protocols. Here's a simple protocol that you could use right now in your calculator. It's called custom string convertible, and it only has one thing in the protocol, which is a var. It's a get-only var called description. Look familiar? Which is a string. And if you implement this protocol, then when you print, if you do the backslash parentheses thing and put your thing inside, it will call this description to get the description of it. So right now, if you said print, quote, backslash, open parentheses, your calculator brain in your view controller, close parentheses, it would probably print out some hexadecimal number and the word calculator brain, which is useless. But if you put colon custom string convertible after your struct calculator brain, now when you print it out, it'll print out the description. In other words, the equation, right? Because you implement description already. I intentionally chose the name description there so that you would implement custom string convertible automatically. But you have to also say that you implement it. You can't just implement description and expect it to work. You have to say, yes, and I implement custom string convertible by putting that on there. So give that a try. Go get your calculator and put this colon custom string convertible, and then in your view controller somewhere, print out your calculator brain with backslash parentheses. See what you get. All right? Another really simple use of protocols is delegation. Okay? That's really where we've all been leading up to here in terms of a use case of protocols. This is not going to use any of the other stuff I was talking about, generics or extensions, none of that. Okay? This is just the simplest possible use of protocols, although it does use Objective-C protocols because there's a lot of optional methods in these protocols. But this is how we're going to implement this MVC thing we talked about, which is blind structured communication. Okay, the delegate and the data source. You remember that from lecture 2? This is how we're going to implement. We're going to implement this with protocols. So here's how it plays out to use protocols to do that delegation. First, view, some UI view thing, okay, like a scroll view, for example, or table view, which we'll talk about next week. It declares a protocol which has all the will and should and did methods I was talking about. So I will scroll to here. Should I allow scrolling in this direction? Those kind of methods. It implements a protocol that just has those methods listed in it. It's going to be an Objective-C protocol. They're almost all going to be optional. All right? So it just declares that protocol. Then the view adds public API to itself, which is a weak property called delegate or sometimes data source. And that type is that protocol. Okay? So anything can be assigned to that var as long as it implements that protocol. The view uses this delegate property in itself to get the answer, should I scroll here, and to tell people, I just did scroll here. Okay? It sends those messages to the delegate because the delegate implements, optionally, the methods in that protocol, so it can send it to them. If it has no delegate, if the delegate is nil, because this weak delegate property, since it's weak, it has to be an optional. All weak properties are optional. So it could be nil. And if it's nil, then the scroll view is just not going to talk to a delegate. It's just not going to ask it any questions or tell it anything. Now, the controller declares that it implements that protocol. That's what it has to say. It has to say at the top, you know, it's view class, UI view, class, calculator view controller, whatever, UI view controller, comma, UIScrollView delegate. So it says, I implement that. Then the controller sets itself as the delegate of the view, which will be legal now because the controller claims to implement that protocol. So it can now be put in a var of type that protocol. And finally, the controller implements whatever methods it wants. Since they're probably mostly optional, it can just pick and choose which ones it wants to, and those did and should methods will now start being sent to it by the scroll view or whatever. Okay? So now the view is hooked up to the controller. The view has no idea who he's talking to. All it knows about its delegate is that it implements those should and did things. That's all it knows. So it's completely generic and reusable view still, but it can communicate with the controller. This mechanism of delegation, you find it all throughout iOS. Any complicated iOS object is going to use delegation when it needs to talk back to its controller in a complicated way. This was all designed, though, pre-Swift and pre-closures, things like that. A lot of times, a closure might be a better solution than delegation. Okay, so delegation, a little bit of what do you call it, backwards compatibility thing, but you still got to know it well if you're going to do iOS because it's just everywhere in iOS. By the way, do not use delegation in your homework assignment 3. I think I might even have made it a required task. You can't do it. Do not use delegation. I never teach you anything after the assignment's already, you know, started to be due. So, yeah, delegation is not for assignment 3. All right, so let's take a quick look at what this looks like code-wise for ScrollView. First, ScrollView is going to have a var called delegate. It's going to be of type UIScrollView delegate optional because it's weak. The protocol UIScrollView delegate looks like this. It's got these optional functions like ScrollView did scroll and give me the view for scrolling for zooming in this ScrollView, etc. Then the controller is going to say, yeah, I implement UIScrollView delegate by doing the little purple or blue or whatever code that is. And in view did load, the view controller is going to say, ScrollView's delegate is me. So ScrollView, please send me all those messages. And then it would just implement whichever of the methods it wants. Okay, and we'll see this in the demo I'm going to do today as well. All right, so that's it for delegation. Let's move on now to the class here, the first class that uses delegation. It's ScrollView. Before I talk about ScrollView, I want to show you a little bit how ScrollView works. This ancient video I have, this is like, I don't know, iPhone 1 or something. But if you look at the way it's scrolling, it actually is very sophisticated. It can have a horizontally scrolling thing, like the stock charts, and inside of it have vertically scrolling ScrollViews. So that's ScrollViews inside ScrollViews. Okay, and ScrollView is smart enough to know whether you're swiping sideways or vertically to make it scroll. Okay? Now, let's talk about how you put something in a ScrollView so you can scroll around in it. You do it by adding subviews to it. So let's review how we add subviews to a normal view. So I create a view like a logo view, and I set its frame, which is where it's going to be in its super view, and then I just add it to its super view. So here I'm saying view.addSubview logo. View is probably the top level view in my view controller. We know that there's a var called view for that. So a scroll view is similar, but before you're doing all that, you're doing a very important step, which is to set the content size of the scroll view. So this is a var content size, it's a CG size, and it's going to be how big a space you're going to be scrolling over. So you've got to set that first. It's very important to set that first. But then after that, you just add subview, just like you did before. So here I added this logo view at 2,700 across and 50 down. Okay, and that's it. So now the scroll view is going to scroll around. Oh, here I added another one. Let's add 2 views. Okay, we got 2 views in there. And now the scroll view is just going to scroll around on this content area. See, it's just scrolling around. In fact, you'll even see the white of the content area while you're scrolling around to do that. Now, of course, you can reposition the views. Let's put this big aerial view up in the corner, and then let's put the Stanford logo so that it overlaps it. And then we can always change our content size anytime we want to not have any extra space, right, and contain the whole thing. So if we do that, then when we're scrolling around, we're not seeing the white background there. Okay? So that's how ScrollView works. couldn't be simpler. It's all about that content size. If you forget to set the content size, ScrollView will not work. If you remember nothing else from this lecture, remember that. Once it's scrolling around, you can find out information about where it is. You can find out the upper left corner, for example, of where the scroll view is using ScrollView's content offset point. And it'll tell you the X and Y of the upper left corner of where the thing is. You could also just say, where is the rectangle that is currently showing the scroll view, where is that showing in the view behind, like that aerial view of Stanford? But to do that, don't forget that those are different coordinate systems. They're different views, so they have different coordinate systems, so you have to convert. Right? You're going to convert the scroll view's bounds, right? The scroll view's bounds, that's in the scroll view's coordinate system. You're going to convert that to the coordinate system of the view, like aerial. See, I'm doing aerial.convert up there, I'm converting that rectangle. Now, why are those rectangles not the same? Well, a lot of reasons. One, you're panning around, so it's always changing. Two, you might be zoomed, so it might be quite different. If you're zoomed in on that scroll view, then that little rectangle might represent a huge piece of aerial, or it might represent a tiny little piece of aerial. Who knows? So you're going to use this method. We saw it when we were doing the drawing example. I converted center from my super view down to my view. Here I'm just converting the bounds of the scroll view from the scroll view to whatever view inside there that I'm interested in. All right. Now, in addition to, so how do we create one of these things? Very straightforward. We drag it out of the utilities area in Storyboard. You can also, it's just a view, so you can do UIScrollView frame if you want, but 99% of the time we're pulling it out. You can also pick a view that's already in your Storyboard and go up to embed and say embed in ScrollView, and it'll put it inside the scroll view. Okay, so that's another way to do that. Then you just add whatever your too big view is, the view you want to scroll around in, you just add it as a subview of the scroll view, but of course you're not going to forget to set the content size. Okay? That's it. It's really quite simple to use. And you can scroll around in there programmatically. Obviously the user is going to have their touch and they can pan around, but you can do it too by saying scroll rect to visible, and it'll take a rectangle and make it as hopefully entirely fit on screen. It'll do the minimum amount of scrolling necessary to get that rectangle on screen. You can do a lot of other things in ScrollView I don't have time to talk about, like controlling that behavior where it only scrolls vertically or horizontally, and it'll kind of on first motion, it'll figure out which one you mean and do that. You can flash the scroll indicators when the thing appears on screen. You can also offset the actual content that you're scrolling over by a little bit. This happens a lot in navigation controllers. Sometimes the bar at the top, which is semi-opaque or semi-transparent, is not transparent enough for the application of this, whatever you're looking at in your scroll view. So you'll offset it a little bit, the content you'll offset by that height of the navigation controller. So there's a whole bunch of stuff in there I can't really talk about. Another big piece of this is zooming. So we've talked about panning around in the scroll view, but you can also use pinching to zoom in and out. So zooming in and out, the way that works, all UI views have a property called their transform. It's an affine transform, which means it has translate, scale, and rotate. And when you pinch on a view, all it's doing is affecting the scale of its transform. It does nothing else. Now, that for most views, for all views, that's going to scale the bits up. So if you zoomed in really big, you'd have really big pixels. It would look really grainy. But if your view wants to, it can make it look really good after the zooming's done. For example, UI image view does that. If you're zooming in on a UI image and it's got more bits of resolution, it'll show them to you as you zoom in. And you could do that, for example, with your calculator. If you had your calculator in a scroll view, which you're not going to, but if you did, if you had the graph part of it, you could, when it pinched in, when it was done pinching, you could redraw the graph to give it nice, smooth curves, right? So it wouldn't be all pixelated. All right? I'll show you how to do that in the next slide. So two things about zooming in a scroll view, though, that you have to know. One is you have to set the minimum and maximum zoom scale. So that's how far you'll zoom in and how far you allow to zoom out. And by default, these are 1.0 and 1.0, meaning no zooming in and no zooming out. So you have to set these to something. So if you set the minimum zoom scale to 0.5, means you'll zoom down to half its normal size. And if you set the maximum zoom scale to 2.0, it means you can zoom out to twice its normal size. All right, so you can decide how much you want to let your user zoom in and out. The other piece is you need a delegate method. Zooming does not work without delegation, and so you have to implement this delegate method called view for zooming in scroll view. And all you have to do is return the view that's in the scroll view, one of the subviews, the one that you're going to zoom on. Okay, and this is the one whose transform is going to get transformed. All right? So, oh, and of course you can zoom programmatically as well. It's not just pinching to zoom. You can set the zoom scale. Here's some examples how to do that. So here I set my zoom scale to 1.2. Now I'm going to set it to 1.0. See, it goes back to normal size. 1.2, I'm zoomed in 20%. Okay? Or same thing with a rect. If I put a little rectangle right there and I say zoom to that rect, it's going to zoom that rect out as big as it can be. Or if I had a rectangle that was bigger and I said zoom to rect, it'll zoom it down so the rectangle fits. Okay, it's going to do the minimum zooming to get that rectangle on screen. There's lots of other delegate methods, at least a dozen more besides that view for zooming and scroll view. For example, if you wanted to do the thing where you zoomed in and then you wanted to redraw to get rid of the pixelation, you would implement scroll, view, did, end zooming with view at scale. And this will tell you when the pinching has stopped and now you can redraw. Of course, if you redraw, by the way, at the new scale, you're going to reset your transform, the view's transform back to the identity transform. Otherwise, you'll be both drawing it scaled and it'll be scaled because of your affine transform as well, pixelated too. So you don't want both of those things going on at the same time. So you would reset your transform here. Okay, so the rest of this is going to be demo. So let me talk about what's coming up here. The demo I'm going to do is a scroll view demo, obviously. I'm going to show you how to do that. I'll show you some other things too, like extensions, things like that. On Friday, we have instruments, okay, performance testing. Really important if you want to do the extra credit in assignment 3, which is a good one, to figure out why your calculator graphing thing doesn't perform as well as you'd like. On Monday, assignment 3, what you're working on now, your graphing calculator, is due before lecture. And then the topic on Monday is going to be multi-threading. We're going to take the demo we're doing today, which is going to be very sluggish, and we're going to make it perform a lot better using multi-threading. On Wednesday, we're going to go into table view, a really important part of UIKit. There will be an assignment, a table view assignment that goes out on Wednesday. It'll be due the next Wednesday. And there's no more reading assignments. I can tell from talking to some of you that you didn't read that reading assignment, any of them, very closely. And you know, I don't quiz you on it, I don't test you on it, because it's kind of up to you how much you want to learn in this class. It's just one of those things where whatever you put into it is what you get out of it. But I really encourage you to at least go through the parts in there that you don't understand and be cognizant of the fact, I don't really understand this, okay? Because then when you graduate from this class, which is, you know, you're getting started with iOS in this class, when you graduate from it, you'll know, okay, that's something I got to go back and really understand better. All right? Okay. So this demo is going to be, again, fresh start. So I'm going to create a new Xcode project, single view application. I'm going to call it Cassini, because we're going to do some stuff with some of the images that came out back from the Cassini probe that went off to Saturn. And I'm going to put it in the same place I put all my apps, a home directory developer. And here it is. I'm going to move XC assets and the app delegate and the launch screen out of the way again. I'm actually not going to move info.plist out, though. We are going to be looking at that today. So we're going to put these in supporting files. Now, I showed you last time how we can rename a view controller if it's got like a generic name like this. You know, another thing we could do to this view controller is just delete it. So I'm just going to go here, right-click on it, and delete it, and remove all references to it. And I'm going to go to my storyboard right here, which still has this view controller. And by the way, if I go look at the identity inspector here for that view controller, it's still trying to be class view controller, even though I deleted that from my app. All right? But I'm going to fix that by just deleting that from my storyboard. All right? So now, no view controller anywhere. Now, I do need a view controller for my app, and it's going to be called Image View Controller. It's going to be a generic, reusable MVC for showing an image. Whenever I build an MVC, I always want to see if I can build a nice generic reusable one, because then maybe I can use it in some other app that I'm building. And also it gives me the discipline as an API designer to think about my public and private API of it. So let's go ahead and do that. Let's create a new file, Cocoa Touch class, of course, and we'll call it Image View Controller. It's a subclass of UI View Controller. Okay, very carefully here. I do not want to put this at the top level. I want to put it down in here where the rest of my files are. All right, so I got my image view controller here. I don't need, for now anyway, any of the view controller lifecycle. I'm also not going to segue from this MVC, so I don't need any of that. I actually am going to be segueing to it, however, because it's a nice reusable image showing thing. So as you can imagine, I might want to be segueing to it anytime I want to show an image. When I have a new class like this, one of the first things I like to do is think about, what is my model? Because the model is what this MVC does. So if I can determine what the model is, it'll help me think clearly about what this MVC is all about. And so this shows an image, so I'm going to have my model, I'm going to have it be public so other people can set my model, and I'm going to have it be a URL of an image. Because what does my MVC does? It shows an image. That's what it is, an image shower. So it seems like having a URL of an image would be a good model for it. Now let's go back to our storyboard here and create an MVC for this thing. So I'm just going to grab a view controller, drag it out here. I'm going to go up to the identity inspector again, and I'm going to set it to be an image view controller. Right? Now, I could start building my UI here by dragging more things in, but I thought it might be valuable a little bit to show you how to build some UI in code. It's going to be simple, but we'll build some UI in code. And what my UI here is going to be at the beginning is just an image view control, or a UI image view, right? I'm just going to show an image using UI image view, this class UI image view. By the way, one thing that's missing here, you can tell by this warning. Let's click on this warning and see what it says. It says image view controller is unreachable. Remember that? There's no way to get to this. That's because there is no arrow that goes into this anywhere. If I were to run this app, it would crash and say, there's no initial view controller. So how do you set the initial view controller? Well, you pick the view controller you want to be the initial one, and you go over here to the attributes inspector, because it's an attribute of that view controller. And down here under view controller, right after its title, is initial view controller. So I clicked that, and look what happened. Got the little entry arrow there. So now when this thing runs, it's going to jump right into this view controller, which is where we wanted to start. Eventually, we're going to have other MVCs, but we'll start with this one. All right, back to my image view controller here. I said I wanted to build its UI in code. I know I need an image view, so I'm just going to start right off with private var image view is a UI image view. And in fact, I'm going to create it right here. There's no reason not just to say this. It's going to create it with basically cgrect0. This is just like saying frame cgrect.0. It's exactly the same as doing that, but we don't need that extra code there. So now I've created this image view. It's in the upper left-hand corner of whatever its super view is. It's not in any super view yet, and it's of 0, 0 size. So it's not that useful, but of course, as soon as I set an image in it, I will resize it to fit that image. And speaking of setting an image in it, I imagine that when I set an image in my image view, I'm going to need to do things like change the frame of my image view and things like that. So I'm going to create a little private var here called image, which is going to be a UI image. And it's going to be computed, and it's going to have a get and a set, so that every time I get or set the image, I can do other stuff. Okay, this is a really kind of simple, clean way to keep, to do ancillary things when you're setting and getting some piece of data. So, for example, when I set this image view right here, I'm going to set this image, I'm going to set the image view's image to be equal to that new value. Of course, that's the primary thing. If I want to set my image, I need to set it in my image view. So this var right here is just the image that this image view is showing. But also, like I said, I want to set my image view's size to fit this new image. And in fact, there happens to be a method called size_to_fit in image view that will cause it to size its frame to fit whatever image is inside of it. So it's nice that it had this nice method for me right here. If I control-check on it, you can read it and see that's what it says. And then how about getting it? Well, I'm just going to return the image view's image in this case. Okay, so this is a var, and it's computed, so there's no storage. And actually, I'm doing the storage here in the image view. Now, this is giving me an error right here. And the error it's giving me is that I need to unwrap this. Well, that's because this image right here is an optional, because image views don't have to have an image. They could be empty at the time. Now, I could unwrap this here, but I'm thinking, you know what? I want my UI to be able to be showing no image at some point. That's perfectly reasonable. So instead, I'm going to change this to be optional. Okay, so this image var is an optional. It can be nil. And when I do that, I want to make sure that I can say imageview.image equals new value. Is that going to work if new value is nil? Yes, it is, because we know that this image view's image is itself an optional. The image view might have no image at this time. It's perfectly fine. Okay, everybody cool? Understand what I did there? It's just a code organization thing. It just keeps me from having to, you know, be resizing this fit somewhere else or to be putting it in some other part of my code that makes no sense. Here it makes sense because here's where I'm setting my image. All right, let's now put this image view into our view hierarchy in code. I told you we were going to do our UI with code. Let's do it. We're going to say view did load is a good place to do this because we know that by the time view did load happens, we're fully initialized. All our outlets are set. We've been prepared if someone's segueing to us. We're in a really good state right now to add more things to our UI. And I'm going to do that just by saying view. Remember, that's this special var in view controller, which is the top level view. Add subview my image view. Okay? So I'm just putting it on there. It'll either be 0, 0 size, or if someone set my image URL, then it might be sized to fit or whatever. Okay? Now, what happens if someone sets my image URL? I better set this image. Okay? And we know a good way to do that, right? It's our property observer here on our model. Anytime someone sets our model, first I'm going to actually clear out whatever image I have. And then I'm going to put the fetching of an image in another method. Remember that this image URL might be an internet URL, and this might be slow internet. This might take a long time. So I'm going to put it all off into this other function here, a private function, fetch image. And it's going to do the image fetching. So how do we fetch an image from a URL? All right? It's actually remarkably easy. First, I'm going to make sure that I have a URL to fetch. I'm going to say if I can let a URL equal our image URL. That's our model. Okay? So if I can get my image URL there, then I'm going to let the contents of that URL, so I'm going to go out on the internet and get the contents of it. I'm going to let that equal data contents of the URL. So data is that bag of bits thing I told you about a few lectures ago. And it has a really cool initializer, which is load up your bag of bits with whatever's at this URL on the internet. Now, this has an error right here. And the error is that this throws. Because that URL might not point to something, or it might be a malformed URL, or it might be a URL to some, bad data or something like that. So if I look at this error here, it's complaining about the mutable, but it's also saying this call can throw, but is not marked with a try, and the error is not handled. Now, here, someone's asking me to show this image URL. I suppose I could catch that error and put up an alert saying, here was the reason I couldn't display your image, but I'm just going to instead use try with a question mark. And if I can't get it, then I just won't show it, which is probably not that great, but it's good enough. for a demo. Okay? So now, as soon as I put try question mark here, this is no longer going to be of type data. It's going to be what type? Yeah, it's optional. See? It's an optional data. Because if it throws, it's going to come back nil. All right, well, since that's optional, I'm going to say if I can let the image data equal the contents of that URL, then now I can create a UI image with that. And sure enough, my image, which is this var right here, is going to be equal to UI image. And image, we all know about image named, but there's also image with the image data. So if you have the actual JPEG data or whatever, you can make an image out of that. And of course, when I do image equals UI image here, it's going to go down here to this setter. It's going to set that image in the UI image view, which we added as a subview, and then it's going to size to fit that image view and show it to us. All right, I got it. Now, there's only one problem with this. There's one thing I don't like about this, which is, well, let's do one other thing too. I'm going to go to view did load here and have it do a demo URL so we can see. I'm going to set my own image URL equal to, and I have these demo URLs here. Okay, it's this little thing right here. Copy that in. These demo URLs have, for example, a little Stanford URL right here, and also some NASA ones, which we'll be doing next time. But I'm just going to use this Stanford URL right here. So our image URL equals demo URLs.Stanford. Okay? Now, what I don't like about the way we've written this code, though, is here in view did load, I'm setting my image URL to Stanford. That's going to go up here and cause this fetch image to immediately happen, which is going to go out onto the internet and grab this image. So as soon as view did load happens, man, I'm out on the internet getting that thing. And that's probably not something you want to do. Why wouldn't you? Imagine this MVC, which is supposed to be reusable, was in a tab bar. Okay? All of the MVCs rather that are in the tab bar, they're all created and view did loaded even before any of them are shown. So if I had a tab bar that had 5 image view controllers right here, they'd all be off on the internet loading things. I might not click on any of them. And I wasted the cellular data plan of my user. All right? So I really only want to go fetch this URL when this view controller is going to appear on screen for sure. So can anyone think of where I would put that instead of in view did load there? Different view controller lifecycle method. How about view will appear? Super view will appear. Okay, so I'm going to do the actual fetching and view will appear. Now, I want to do this. No, okay, there's another problem though. What if I'm already on screen and someone sets my image? Then I can't do it in view will appear. I got to do it right away. So I kind of really just want to delay doing it to view will appear if I'm not on screen already. So what I'm going to do up here, with my image URL up here, is I'm just going to check and see if I'm currently on screen. And if I'm not, sorry, if I am, so I'm going to here say if my view window is not nil, then I'm going to go fetch this image right away. Okay, so view, remember that's the var, that's the top level thing. Window is a var that is in all UI views. It tells you the window it's in. And if you don't have a window, it means you're not on screen. If you do have a window, you are on screen. So if my view.window is not nil, then I'm on screen, I'm going to go in and fetch. Otherwise, I'm not going to fetch. And instead, down here in view will appear, I'm going to say if my image is nil, so if I don't have an image yet so far, then go fetch it. So you see how the combination of these two things is going to wait to fetch it until view will appear. Unless I'm already on screen, then it'll fetch it right away. So that's at least delaying it. So now if I were in tab bars, when I clicked on the tab, view will appear would happen and I would load up. And if I did something that caused the image to change, it would change right away because I'd be visible. If I went off screen and clicked on another tab, my image was changed, it wouldn't change. When I click on it, then it would go get it from the internet. So I'm minimizing the amount of data plan usage if the person is doing it over cell. Okay, so I think we got everything we need here to make this work. Let's try running. Let's go on an iPhone 7. Hopefully our network works on this laptop here. Okay, so it comes up here and it's not showing. Where is our image? We don't have any image. Well, I think I see something in the console down here. Let's see what that says. It says App Transport Security has blocked a clear text HTTP. It's insecure. Of course, we know HTTP is insecure. HTTPS is secure. It says temporary exceptions can be configured via your app's info.plist file. Luckily, I didn't move my app info.plist into supporting files because I knew this was going to happen, obviously. So what's going on here? Well, if you look at the URL that we're trying to load, this Stanford URL, see, it's an insecure HTTP URL. And by default, iOS does not let you load those up. You have to say that you're willing to load those up, untrusted URLs. And you do that with this info.plist. So what is an info.plist? It's really just a list of some settings, some configurations. For example, it shows, will you run in portrait mode? Will you run in landscape left and landscape right? Those kinds of things. It's really kind of runtime configuration that how your app will run. So we can add this app transport security that we need right here by right-clicking. Okay, we right-click. Pay attention here because you're going to need to do this probably maybe in a future homework. But we're going to right-click and pick Add Row. So that's going to add a row. Oops, we don't want to add a row there. Sorry, that added a row to our supported interface configuration. So we want to be not selecting that and do Add Row. And if you go look in Add Row, right near the top is App Transport Security Settings. You see it right there? So I'm going to click on that. And then I'm going to open the security settings. Don't forget to open those settings. And then hit plus, which will add a security setting. And here you can see the options. And we want the one which is allow arbitrary loads. We'll allow any HTTP URL to be loaded. And we're going to go over here and say that that is yes. So allows arbitrary loads, yes. Okay, so we just add this our info plist. Now when we run our app, we've given permission essentially for the app to load these HTTP non-S URLs. Okay, there we go. Look at that. Woohoo, we got Stanford, and we can even rotate. Good. Now, of course, we can't see the whole image here, and we can't zoom in. It'd be nice to be able to zoom in. For that, we obviously need a scroll view. So how are we going to put a scroll view in here? Well, this is a good opportunity to show you mixing code for doing your views in code with doing it in the storyboard. So I'm going to put my scroll view in the storyboard, and we'll leave the image view in code. Okay, so you see them both working together. So to put a scroll view here in my storyboard, I'm going to just search for scroll view down here in the utilities window. There it is. I'm going to drag out a scroll view. Here it is. I'm going to use the blue lines to put it in the whole, filling my whole MVC here without even any borders. Then I'm going to use this little reset to suggested constraints, remember that? To have it do the auto layout for me. Then I'm actually going to go up here to the size inspector right here and click on it to double check what it did in terms of constraints. And sure enough, it's done exactly the constraints I want. All right, so we have this. We want to talk to the scroll view. Of course, we need an outlet to it. So let's get our controller on screen at the same time here. And let's control drag. I'm going to put it to scroll view down here by the image view. So let's control drag right into our code right there. It's an outlet. It's a scroll view. Notice it's weak. We talked about why our outlets are weak. I'm going to call this outlet scroll view because that's what it is, our scroll view right there. Now I want to integrate the image view into the scroll view. So I'm just going to, when the scroll view gets set, I'm just going to add that image view as a subview. Okay, and now I don't need to do that in view.did.load. Where is view.did.load? Okay, don't need to do adding the image view as a subview of our top level view because now I'm adding it as a subview of the scroll view. All right, make sense? So let's see if that just works. That should just work. Yeah, it's good. And you should all be thinking about, why wouldn't that work? Because I'm going to ask you why it's not working in a second. All right, here it is. It looks like it works. Let's scroll. Oh, we can't scroll around. Why? I know I put a scroll view in there. How come the scroll view is not scrolling? Anyone have an idea? Okay, he's saying the two variables, the zooming things. Well, that's true. That's why it won't zoom. But it won't even pan. Why won't it even pan around, let alone zoom? Content size, exactly. We haven't set the content size. So this scroll view actually is panning around the content size. It's just that the content size is 0, 0 in the upper corner here. So when you are trying to pan around, it's like you're not even over that 0, 0 spot, and it's impossible to be over it. So we want the content size to be encompassing this whole image view so we can pan around with it. So let's do that. Now, where do we want to set our content size? There's actually two times that we want to do it. For sure, when our scroll view is first hooked up here, we're going to want to set our content size. So I'm going to say the content size here equals, and what is our content size going to be equal to? Well, it's our image view's frame size. Okay, we want to enclose our entire image view. So whatever the size of our image view is, that's what we want the content size of our scroll view to be. But there's another time we're going to want to set the content size, which is if our image changes. Right? If you put a new image in there, then we're going to adjust our content size to make a change. And luckily, woohoo, we have this nice bar down here so that every time we set our image, we can do things. And sure enough, right here, I'm just going to say scroll view.content size equals the image view's frame.size. Now, this might seem good, but actually this is very bad. And the reason for that is that if we're an image view controller and we're getting prepared, someone's going to set our image URL. That's how they're going to prepare us, right? So let's follow what that's going to do. So image URL is going to set the image to nil down here. Set this image to nil, and it's going to try and execute this line of code. And that is going to crash because when we're preparing, our outlets are not set. So this is nil. So the way around that, question mark, just optional chain. If it's nil, I won't be setting the content size of the scroll view, but that's okay because later I'll come along and do it here when the outlet does get hooked up. So this is just to remind you that anytime you're accessing outlets in methods that might be called during prepare, you need to optionally chain them, okay? So it doesn't crash your app during prepare. All right, so let's go ahead and see if that fixed everything. Set our content size here. Should be good to go. All right, here's our image and, ooh, look at that. Scrolls nicely. Rotate, okay, scroll. Now notice it has a kind of this little thing where you scroll too far and it bounces back. You can control that, by the way, in the scroll view. It's one of its settings. All right, oops, wrong rotation there, okay. We got it now. Of course, now we'd like to zoom in. We want to look and see if we can find any of ourselves down here. Maybe that's one of us right there. We want to zoom in and see. But for zooming, as he was saying up above, we need to make sure we set the minimum and maximum zoom scale, because actually the minimum and maximum zoom scale are set right now. They're set to 1.0. So that's minimum and max means no scrolling. All right, so let's set that. A good place to set that is probably when our scroll view is first hooked up as an outlet. So we'll just do this here. We'll say scroll view dot minimum zoom scale. Let's go really small. How about 0.03? Okay, 3% of the size we'll allow our image to be really small. And maximum, just to show you the difference, we'll make it only so we can only be twice as big. Okay, or we could even make it so it can't be bigger. Right? 1.0 would be, it can never be any bigger than it is. It could be smaller, but not bigger, which we might want because if it's allowed to be bigger than its natural size, it's going to start getting pixelated. Maybe we don't want that, but just so you can see it happening. And what's the other thing we need to do to make zooming work? No one remember? We need delegation. Yes, the scroll view needs to know which of its subviews you want to have the transform change. And it does that by asking its delegates. So now we're going to get to see delegates in action right here. So to make a delegate work, you need to set the delegate to be yourself. So I need to say scrollView.delegate equals myself. Now this is not legal. And this is going to generate an error. And hopefully you can kind of see why. We'll look at the error. And it says, you cannot assign the value of type ImageViewController, which is what self is, to the type UIScrollView delegate, optional. So I told you that the ScrollView delegate is an optional UIScrollView delegate protocol, and that's what it is. And of course, self isn't that, even though it doesn't implement any methods, and that protocol has only optional methods, because it needs to go up here and say, yes, I'm a UIScrollView delegate. Okay, so this is this class UIViewController saying, I conform to this protocol. And as soon as I do that, the error goes away, and there's no errors. Even though I didn't do anything, I didn't actually implement the UIScrollView delegate protocol. That's because all the methods in UIScrollView delegate are optional. So I don't implement any, but they're all optional. So I've conformed to the protocol. But of course, that's not going to help us with our zooming, because we in fact do need to implement a method. Now, I'm going to show you a cool way to do this with extensions. I'm going to add protocol conformance to my ImageViewController with an extension. And I'm going to do that like this. So I'm going to make it so that it does not conform. Okay, ImageViewController does not conform. But I'm going to add an extension down here at the bottom of my file, which is an extension to the ImageViewController, which causes ImageViewController to conform to the UIScrollView delegate protocol. Okay? So by just putting this here, this error down here is going to go away, because I've added an extension which causes this class right here to conform to this protocol. Again, all the methods are optional, so normally we would have to put a bunch of methods in here. But I am going to put the one method we do want down here, which is view for scrolling view for zooming in ScrollView. Now what's interesting, notice as I start to type this, it actually knows that I'm a UIScrollView delegate, so it offers me that method as a choice. So I'll double click on it. Here's my view for zooming in ScrollView. I just need to return which view I want to zoom in. For us, of course, it's that image view. So I want to just say return image view. But that doesn't work. Why do you think that doesn't work? This image view is private. Okay? Now, I could unmake it private, but now everyone can see that image view. And that's a little too unprivate. So there's another kind of private called file private. And what file private means is it's private to everyone in this file. Okay? So that allows this extension to see this image view. And it's still private to everyone else. Everyone using my MVC who sees this other files, it's still private. They don't see it. But this guy can use it. Okay, so that's a different kind of private, file private. All right, so we got the view for zooming. This is, in fact, the view we want to zoom. So let's go ahead and take a look here. All right, here it is. We can still scroll around. And if we hold down the Option key and get our two fingers here, we can also zoom. Okay, and we can zoom in really small, and we can zoom out. But notice it won't let me zoom any larger than 1.0 because I set that as my maximum zoom scale. All right. So the last thing I'm going to do, well, I'll leave this as is because I'm going to post this code like this and you can play around with it. Next time what I'm going to do is add another MVC that lets us pick some NASA images, these Cassini NASA images. And one thing we're going to find about those images, they're huge. And even on our Stanford network, they take a long time to download. And that's going to be annoying. And so we are going to use multi-threading to keep our UI responsive, even though it's doing this very expensive thing, which is downloading this huge file. All right. So I'll see you then.
For more, please visit us at stanford.edu.